Okay.
Okay, so again, like I said, I haven't taken a big chance to look at it because I was busy at work.
Yeah.
But if you want to get it started.
Yeah. We can start. Yeah, let's start it. I've already started recording. We're good to go.
Okay.
I got it pulled up. So question 1 and 2, you should be able to answer.
Yeah. Mm-hmm.
Question 3, which hypothesis involves equality? That one, I have no idea, to say the honest truth. Let me quickly look up that one. That one didn't make any sense based on what I read, because I did all my reading and I was like, equality could be, well, not equality would be the alternative hypothesis. So I'm going to say it's the null hypothesis, but let's check it. Luckily, there is a search function. Look. Yeah. The null hypothesis is expressed in a statement involving equality. So it is the null hypothesis.
Okay, that's what I was thinking. I kind of read really quick.
Yeah. This lesson, like, there's a lot of technical terms, but it's not that difficult. Pretty much. So number 4 was, remember that the p-value is the probability of attaining sample statistic. When computing the p-value, which hypothesis do you assume to be true? It's always the null hypothesis.
Do you have the ebook open?
Yeah.
Send me the link here on the chat window. See if I can open up where you found that one. No.
Yeah. Give me a second. Copy. Come on. Go. There it is. Do you have problems opening the book? Or is it just difficult to get to?
I have to save it on my tabs.
Yeah.
Because every time that I try to look it over, I'm like getting the wrong place.
Yeah.
Okay.
Let me know when you're ready to. Did you get it open?
Hang on. Okay. Yeah, got it.
Okay. So question 5, suppose the null hypothesis is that the mean equals 10. And then for question 5, which of the following represents an alternative hypothesis for a two-tailed test? So a two-tailed test is whenever the alternative hypothesis means that it basically just is exact opposite. So it means that the mean does not equal 10. So it would be, for me, it's the third one down. The mean does not equal 10. Question 6, which of the following represents a left-tailed test? I'm pretty sure that left-tailed means that the mean is greater than
10.
Than 10. But let me check that really quick.
Okay.
Okay, it's when the mean is less than 10 is a left tail.
On what segment on the book do you find that? Is on 3.2?
4.1.
4.1. Okay.
So what I do is I just Control F and bring up the search function, and I just search left tail.
It let you do that there?
Yeah.
Okay, cool. Okay, that should come in handy then. All right, and we said that it was negative.
Yeah.
Less than 10, right?
Less than 10.
Okay, got it.
And then 7's going to be the exact opposite. So a right tail is when the mean is greater than 10.
Right. Okay.
All right. So the p-value to the level of significance, or alpha. So alpha is a number that the book says will, or basically they said they'd always give us, which is the level of significance. If the p-value is ever greater than alpha, then we do not reject the null hypothesis. When it's less than alpha, we do reject the null hypothesis. So that first question, yeah, for A, which one would result in failing to reject the null hypothesis? It would be p-value greater than alpha.
Okay.
And 9 is the opposite, p-value less than alpha.
Less than alpha.
Yeah. Okay. And I think that's where, after this, I haven't done them, so I'm going to have to read the questions through. So insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average amount of the claim was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Okay.
Right.
So that would mean the null hypothesis equals 1,500, and their alternative hypothesis is going to be greater than 500 or 1,500. Which of the following would be the appropriate? The average claim amount is greater than 1,500. It's going to be.
So on mine, I have the A alpha would be the third option. The average claim amount is greater than the 1,500.
Yeah.
On an
Yep.
online class meeting?
And the number 11 for HO would be, we said that it would be less than 1,500, correct?
HO is the null hypothesis, so it's what they originally thought it would be. So it would be equal to 15.
Oh, okay. So that's option 1 for me. I don't know if it's the same for yours.
Same for me. Okay. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Okay. The insurance company assumes the distribution of the sample is normal. Is this a good assumption? Yes.
Since the population is normal?
Since the sample size is large. They said anything over 30 would count as a large sample size. That's when that central limit, limit theorem comes into play, and it should make for normal distribution.
Right, because normal on this sample it's 40, so it's over.
Yeah.
Got it.
Yeah. And what theorem or law justifies the answer to the previous question? That's the central limit. Okay. So 14. Which of the following is the test statistic as defined in the lesson? I believe that is going to be.
You said Control F helps you.
Yeah. So you hit Control F. It brings up a search bar in the top right.
Not letting me do on mine. Do you have to just press Control F or Control Option F?
So you hold down. For me, I just hold down Control and push F. It's a shortcut for find.
I wonder if it's different on mine.
Do you have a Windows or a Mac?
Mac.
That's probably why.
Oh, you have Windows?
Yeah.
Okay,
I know you can do it still. I just don't know what the shortcut is for you.
Yeah, I think I'm gonna have to look at first. All right, never mind. I'll do that later. All right, so going back to number 14, we said that it was what?
It is going to be the Z-score for. So our test statistic is actually going to be the Z-score for the sample mean. Okay. So the historical mean of sales receipts in a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis with the test hypothesis. So there's null hypothesis equals 150. Oh, so my wife says for you it should be Command F. Should give you what you're looking for.
Okay. I'm going to see if it works.
Go for it.
That's what it is. Thank you.
So there's the test, and the alternative hypothesis is that the average is less than 150. She'll use the level of significance alpha as 0.05. Then she takes a random sample of 36 sales receipts from her store, and there's the mean. Okay, so we've got everything we need. We just need to calculate the z-score for this. Can you have any okay. So the z-score is going to be 144 minus the 150. And then that's going to be divided by, no. Buddy. Is going to be the standard deviation of 40 divided by, hold on. Let's do this first. So 40 divided by the square root of the sample size, which was 36. All right, and then 144 minus 150 divided by that number. Okay. So our z-score, did you get one?
No.
I mean, I got, what is going on? I got negative 0.900.
Okay.
And so the p-value associated with that z-score is the exact same thing. So it's negative point or negative 0.900. Right? I'm pretty sure that's how that works.
Okay.
Let's check. Yeah, so it's the p-value minus the negative, or it's the z-score minus the negative.
Mm-hmm.
So for question 15, it would just be 0.900. Oh no, for question 15, it is negative because that is the z-score.
Right. And then same thing for 16.
16, yeah, it's just 0.900. So in this case, our p-score is higher than the level of significance, which means we would actually fail to reject the null hypothesis.
Okay.
And in that case, we have
sufficient evidence of the true population.
This is where I don't like this because we can't ever accept it.
Mm-hmm.
So we have to say that we have insufficient evidence that the true population is less.
Okay.
Is basically what we're saying. We're not saying that the null hypothesis is correct,
but there's not sufficient.
Yeah, we're just not rejecting
it. Number 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Okay. So this one involves, there's a matrix that has it on it, and I believe that if you fail to accept the hypothesis, the null hypothesis when it's true, that is a type 1 error.
Yeah, it talks about it on section 4.5 in the book.
Okay. I'll check. Yeah.
Okay.
So
We said which one?
Hold on. Got so many things open. Okay. The which involves rejecting the null hypothesis when it is true.
Huh.
So, yeah, that's a type 1 error. Type 1 is when you reject the null hypothesis even though it is true.
That is negative. Right. Okay.
Okay. So a researcher decided that instead of using the level of significance alpha 0.5, he will use an alpha 0.
0.01.
Yeah, a 0.1.
The probability. So he's decreasing the level of the alpha measurement, right?
Isn't he? He's decreasing it, right?
Right. Yeah, because it goes from 0.05 to 0.01.
Right. So would we be more likely to accept a false null hypothesis? Which to me sounds like a type 2 error. Because if the null hypothesis was false and the numbers put it below a 0.5, making it false, but above a 0.1, we would still accept it as true. Does that make sense?
Yeah.
So I'm going to say
so it's a type 2.
Error will increase.
If a alpha equals 0.05, compute the probability of committing a type 1 error.
And this I was a little confused about.
What's the formula that we use?
Hold on, I think we have to use the applet. But I've got to check. Oh man. So I think what we do is I think we use the applet and consider the 0.05 to be a z-score, if I'm correct. Oh, I have to look.
Picnic my daddy.
I'm trying to look for that formula.
What is the value of alpha? The value of alpha is the probability of committing a type 1 error. That's what I want to know. Come on. Oh. What? Is it asking for the probability?
No, it just says if alpha it's equal to 0.05, compute the probability. Oh the probability of committing a type 1 error.
So the book says we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05, which is equal to 1 over 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at a point level 5. So a point level 5 would, I mean, the probability would be 0.20. At least that's what makes sense to me. If it's a 0.20, 1 in 20 chance.
20%?
Yeah.
Okay.
It's round 2 decimal places. So let me submit this and let me see how we did.
See how it works. Okay.
I am submitting. Okay, we got. Is that the only question? No. Okay. So we got the last question wrong.
Mm-hmm.
And the only other question we missed, I didn't put a negative 0.9 for the p-value.
What question was that?
Number 16.
Oh, but we did say that it was a 15, it was a negative 0.900. And on 16, it was a positive 900, wasn't it? 0.900?
And that's the one we got wrong, is 16.
Oh, okay, so both of them are negative?
Well, let me check real quick, but I'm pretty sure, yeah, that's what's gonna.
Mm-hmm.
Let me check. More stream. Okay, so. Okay, I got it. So what we need to do is we need to plug the z-score in 0.900 to the applet. And our probability is whatever area is on the outside of both sides.
Mm-hmm.
So it's actually she said 3 decimals would be 0.368 is actually what it would be.
I can't find my applet.
All right, so. I still don't see how we would calculate. The probability. Yeah, see, I don't see anywhere where it says how to calculate the probability of alpha.
Yeah, that's what I was looking for too. I don't know if this helps, but on the summary, all the way to the bottom on a yellow or orange box, it says the p-value is the probability of getting a test statistics at least as extreme as the one you got. Assuming I chose null is true, a p-value is calculated by finding the area under the normal distribution curve that is more extreme. The alternative hypothesis tells us whether we look at both tails or only one.
So, but that would just mean that we would need a p-value of 0.05.
Mm-hmm.
Well, here, do this for me. So, did you fix the? Did you fix question 16?
Yeah, I put a negative 600. I mean 900.
No, change it to. It's actually sorry. So if we put the z-score into 68, is what the p-value becomes.
What is it?
0.368.
Okay.
And then change the last question to 0.05 and submit it, and let's see what happens.
Okay. And that C 0.05 is positive, right? No, not negative.
Oh, of committing a type 1 error. Maybe that's why. Hold on
Okay.
really quick, just because I don't know. Because it says it's just of committing the probability of committing a type 1 error. Okay. Yeah, type in 0.05 and submit it and see what you end up with.
Okay. All right, submitting now, and we'll see. Nope, still missing one.
We're still missing that last one, isn't it?
No, actually, with that one we got it right, but we're still missing on number 16.
We still got 16 wrong?
Oh no, 18. 18. I got 18 wrong for some reason.
Oh. Did you put we have insufficient evidence that the true population mean is less than 150?
Yeah. We have sufficient. Oh, okay, now that's where.
Insufficient.
Yeah.
All right, so we got 21 and 16 right, correct?
Yeah. Those two
Okay.
are good. It's just 18, the one that I need to fix.
Okay. So I'll go retake the quiz. I figured out how to look at past answers, so I'm not too worried about it.
Okay.
Okay. Wish I could open these up in the same place. Okay. Okay. So the z-score was negative 0.920. And the p-value was 0.368. We failed to reject the null hypothesis. We have insufficient evidence. Okay. Step 1. Zero. Dumb question, that last one. I still missed one. Which one did I mark wrong? I still got 16 wrong. Oh, I'll
What?
probably put it in. How did I get that?
No,
one
because
wrong?
16 is the 0.368, right?
Yeah. Do you have that one right?
Oh, no. I have that wrong too. I just noticed.
Dang it. Well, I've submitted again. Have you submitted yet?
No, not yet.
Okay, hold on. Let's go back to the p-value.
I thought it was only from one, but apparently that one.
In advance, clicks in the data. The p-value is in plus or minus the z-score to the left, to the right. Yes, that is correct. Was my z-score not exactly? I thought it was.
Yeah, because I think you went and check it, didn't you?
Yeah. 144 minus 150 divided by that number. Yeah. Oh, gotcha. So, because this is, what is this? A left-tailed or a right-tailed? Because we're looking for it to be, okay, so this is a left-tailed, which means it's only the area to the left.
Mm-hmm.
So the z-score is actually 0.184. Yeah. So type in 0.184 and you should get all of questions correct.
Hold on, let me check on that.
You're good.
What'd you say? Point what?
0.184.
Okay.
That was not something I noticed in the lesson. It was a little vague. Do you need any of the other answers for any of the other questions?
No, I'm going back to it and making sure that I'm not missing one.
Okay.
Okay, so I'm gonna go ahead and submit it and see what happens.
Let's see.
Yep, that was it.
Perfect.
They're all correct now.
Good.
So was it because it was a left
Yeah.
tailed?
So when you're doing the p-score is equal to whatever in the applet the area is that it would be either, it would be more extreme to get. So because this one is a left, because we're only looking for what is less than the z-score, which in this case happens to only be 0.184 of the area, that's what it would be. If we were doing a null hypothesis that said, or an alternative hypothesis that says that the mean does not equal 150, the two-tailed, it would have been both. It would have been that 0.3681. It would have been on either ends of the extreme.
Okay.
And then a right-tailed would just be the right side.
Got it, the other side, yeah. Well, okay. Well, that helped. Hey, really quick, could you again post here on chat the link for the applet? I thought I had saved it, but I can't find it right now.
Yeah, you're good, man. There's the applet. It's that one bottom.
Yeah, got it. All right, perfect.
All right, man.
Well, happy birthday to you.
Thanks.
Sorry that you had to do all this today.
It's all right. That's what the weekend's for.
All right, well, I'll see you Monday then, right?
Yeah, let's plan on 5.
All right.
And I'll email Michaela and see.
Hopefully she's back by then. Yeah.
Yeah, let's hope. Okay. See you, man.
All right, later, man. Thanks.
Bye.